Okay, so let's start. So can you see the slides?
Yes, sir.
Yeah. First, the just to recap a little bit, there was this stop and wait protocol. That is the simplest protocol where one frame is sent, once it is received, an acknowledgement is sent, and then the other send is sent by the sender. If you look at this diagram, it makes it look as if only one party is sending information and the other party is sending only acknowledgements. In reality, this is not the case. In reality, the acknowledgement is piggybacked or superimposed on the same message. It's combined on the same message, which delivers the same segment that delivers the information also. So what will happen is between the parties A and B, both of them will be senders and both of them will be receivers. That image has not been shown here for simplicity, but in reality that is the case. Okay. Usually TCP or any the transport layer entity that we are going to study, that is TCP, that protocol, that is a bidirectional protocol. Okay. So in that case, what you do, you superimpose this information, whatever data you want to send on this acknowledgement also. So what will happen is that A will also acknowledge any segment that it receives from B. Okay. Now in the discussion of these slides in this context, there are two different conventions used. One convention is the acknowledgement number acknowledges that up to this packet has been received. But there will be certain situations where the acknowledgement number basically depicts the next expected packet from the other side. I will clearly mention what is what. Okay, which one is being, which convention is being used, I will clearly mention, and you should remember that so that there is no confusion. In practice, TCP uses the convention of the next expected packet number, this convention. Now, coming back to the stop and wait protocol, this is very simple, but if you look at it, it is very slow. Okay, because unless the acknowledgement of one single segment comes back, the next segment is not sent. So it is very, very slow. In particular, when you have a noisy channel, which are all real channels, okay, no real channel is perfectly error free. In those cases, depending on whether a frame has been lost or segment has been lost or whether the acknowledgement has been lost, the retransmission happens. The retransmission is based on a timeout mechanism. These are software uh, timeout mechanisms implemented for every segment. The software timeout mechanisms in turn take help of a system clock and interrupt based timeout mechanism. I will not go into the details of it. If you are interested, you can refer to the textbook by Tannenbaum, where Tannenbaum describes a relatively simple linked list based scheme to implement the timeout interval for packets. Okay, it's not very difficult to understand. You can have a look at it if you go where I'm like how this timeout is implemented. Now, what happens here is that suppose as soon as a frame is sent, the sender starts a timer corresponding to that frame, and it expects that within a certain interval of time, which this timeout interval, it keeps on estimating continuously and updating. We will come to that. How does it estimate? Probably later on in the when we study TCP in greater detail, but somehow it estimates and also updates. It's not that it is constant all the time, it changes. It expects that the acknowledgement should come back within that time, okay, from the other side. If it does not receive, it has no idea of what happened, whether the packet that was sent got lost or its acknowledgement got lost, that is not clear to it. So it retransmits. The only thing it can do is it can retransmit the packet, and that is what it does. When it retransmits the packet, the other side either can receive it or it might not receive it. And if it receives it, it sends back an acknowledgement. And then the other side can proceed with sending packets, etc. Similarly, the other side also, in the other side, in this picture, which shows an asymmetric data sending and sender and receiver picture is asymmetric, which means one party is sender and one party is receiver. The other side is not implementing any timer. It only acknowledges, that's all. It does not expect that its acknowledgement itself will be acknowledged. But if the other side also acts at the sender, then both sides will operate with timers. Okay, so that's a complicated picture. Later on, probably we will have chance to look at it. For now, just to be keep things simple, just consider one-sided timer mechanism. So as it was discussed, that because your window size is 1, there can be it is sufficient that you work with 1-bit frame numbers or segment numbers. Okay, so in that case, frames can be identified and acknowledgements can be identified with numbers 0 and 1. Look at this picture. In this picture, they follow a convention where the acknowledgement number is the corresponding to the frame that has just been received. Okay, already which has been received. This convention is being followed. But as I said, that there could have been other convention also where the frame number corresponding to the next expected frame could also have been used. So here frame number 0 is being sent and it is being acknowledged. Frame number 1 is being sent, it is being acknowledged. Now, after frame number 0 is being sent, for a long time, A does not receive any acknowledgement for another new frame number 0. Please understand that this frame 0 is different from the initial frame 0. This frame 0 is just the number is 0, but the content is different. Okay, the information that is being sent in this frame 0 is different from the information that was sent earlier. The number is still 0 because it kind of cycles back and it is only between 0 and 1. Now, when the new frame 0's acknowledgement does not come back within expected interval of time, frame 0 is set to timeout because its timer expires. And when the timer expires, the sender A again resends frame 0. This time, luckily, it reaches B and then it is acknowledged. In this way, it continues. Similarly, for frame 1, the other situation happens, a complementary situation where the acknowledgement gets lost. However, the sender has no way of knowing, A has no way of knowing what happened, whether the data got lost or the acknowledgement got lost. So it resends frame 1. This type of timeout based automatic retransmissions are generally called automatic repeat request or ARQ protocols. So there are these bombastic state diagrams. You can have a look at them and you will understand. These are taken from Kuros and Ross. This one and I think this is the sender. The receiver one is not shown here, but basically these are not very difficult once you understand the mechanism and the protocol. You can just read the diagrams and you will understand. So as I mentioned that stop and wait is very slow, so we need to go for something which is faster, which is called a sliding window protocol. Okay, in the sliding window, multiple packets are transmitted, possibly transmitted if they are ready at one go. The idea is similar to computer architecture pipelining, where you try to execute multiple instructions overlapped way, in a sense that all instructions are kind of get partially executed every clock cycle, and finally you at the end of every clock cycle you get one instruction output, exactly one. So here it is slightly more complicated. The complication is by the fact that the rate at which the data segments are generated from the sender and the rate at which the data segments are removed by the receiver, these are not constant over time. What I mean by that is that an application might generate plenty of data segments at any given point of time. For example, right now we are kind of talking over this Microsoft Teams application. So a lot of segments are UDP segments probably are getting generated from my system onto your network. Onto your network, on the other hand, those of you who are receiving these data segments, you are probably sending, well, if it is UDP, probably acknowledgement, etc. also aren't being sent. Okay, so you are mostly consuming these segments without sending back anything. Okay, so the rate at which my application is generating outgoing segments is quite high. Okay, whereas the rate at which your applications are generating outgoing segment is almost. Two are completely different. Similarly, my application is currently probably not consuming too many incoming segments. Okay, so this type of depending on the application that is taking help of the transport layer service, the rates of sending segments outward and inward, they vary and they can control many different ways in which they operate. So this is an important factor. The rates of data generation and data consumption are important factors in controlling the performance of these pipelined systems. Anyways, coming back to the protocol themselves, now there is a set of sequence numbers corresponding to outgoing frames and a set of sequence numbers corresponding to incoming frames. Okay, one is called the sending window and the other is called the receiving window. Okay, so the sender, so each outbound segment now contains a sequence number from 0 to some maximum. Okay, say 2 power n minus 1 for n bit sequence number. And there is a sliding window and a receiving window. Please understand that this 2 power n minus 1 is not the sliding window size. Okay, this is not the sliding window size. This is a sequence number space, 0 to 2 power n minus 1. So the concept of sequence number and the concept of sliding window are different. The sequence number in practice, in real protocols like TCP, the sequence number space can be quite large. Maybe say 32-bit sequence numbers. In that case, your segment numbers can vary between 0 and 2 power 32 minus 1. After that, the segment numbers would again kind of come back to 0. Again, it will start from 0 because you will run out of sequence numbers. Any finite bit arithmetic integer space, after you end the upper limit, it comes back to 0. So that is the sequence number space, and the slide sending window and receiving window, their sizes are slightly different. There are connections of sequence number and window sizes, which we will see very soon. There are certain limits which they have to kind of abide by, otherwise the system does not work because of this mechanism of the sequence numbers coming back to 0, this issue. Let's see the sliding window protocol. Please pay attention, okay, because this is it's slightly complicated, so you should pay attention. Notice this rectangular boxes on the sender side and the receiver side, and on the sender side, in these boxes, the ones shown in green are the packets which have already been sent out. Okay, now the sending window basically slides to the right, and similarly the receiving window also slides to the right. Okay, now initially your sending window is between 0 and 6, so the window size is 7. Okay, and the maximum sequence number here is between 0 and 7. There is a reason why this has been used. This range of sequence numbers and these window sizes have been used. This is kind of a limit, as we will see very soon. You cannot make the window size any larger, otherwise you will be in trouble. Okay, which we will see very soon. But anyways, these are 3-bit sequence numbers between 0 and 7, and the window size is 7. Window size is also 7. First, the window is on the sequence of numbers 0, 1, 2, 3, 4, and 6. What does this mean? This means that if the application layer generates segments with numbers 0, and those segments are numbered between 0 and 6, they can be sent out. They are allowed to be sent out. This is the meaning. Okay, so the sender window allows this to be sent out at a time, and it will not, when it receives acknowledgement for something, it slides the window rightwards, saying that I have sent it out and I have received the acknowledgement properly. So everything is fine with this segment. So we can now proceed to the next segment. Until it receives an acknowledgement, it does not proceed rightwards. Okay. So notice this diagram. So the frame 0 or segment 0, whatever you called, you send it, the receiver is receiving it. This diagram shows a situation where there is no error in the channel and everything that is sent out is perfectly received. This might not be the case, as we will see very soon in the next diagram. Now, then it sends out frame 1 because it is allowed to be sent out. It is in the interval 0 to 6. Acknowledge when the receiver receives it, it sends an acknowledgement. Okay. Please note that the acknowledgement here, it was sent after frame 1 had been received. It could have been sent before frame 1 had been received also. In this case, it was sent after frame 1 was received. Why? Maybe because the receiving side was busy with something else, so it could not send out the acknowledgement immediately. Okay, maybe frame 1 was received very fast, quite fast, so it got busy. It was in receiving the frame and then it handled the acknowledgement, whatever. Okay, then frame 2 is sent. After it sends the acknowledgement of a particular frame, the sender window in its turn also moves slightly to the right because its job is over about that segment. Okay. So frame 1 is sent, frame 2 is sent, frame 3 is sent, frame 4 is sent, etc. And as the corresponding acknowledgements come in, the sending window moves to the right, and the ones shown in green are the ones for which frames have been sent outwards, but acknowledgements are pending. They have not yet been received. Notice that once the frame moves 2 position to the right, the sender frame, it now takes in the sender frame 0 now comes to the right in the inside the frame, which means this segment number 0 in the new cycle is now an allowed frame to be sent. So whenever it finishes sending the 7 frames up to frame number 7, which is 8 frames, it will start numbering the new frames with starting from number 0, and it will be sent. Please note one thing, it does not move the window rightward until it receives the acknowledgement for a frame. So that it is not allowed to do. Okay, so in this way it works. However, a real life example, this I think I explained this, is a not that good example because they are very restricted. What happens when in a noisy channel, if a segment or its acknowledgement is lost and it is not received? Okay, so if a timeout will happen. Now there are 2 options. One option is, say if segment N is lost, all the segments from segment 0, that is start of the sliding window. Segment 0 is the start of the sliding window. Okay, not the, don't get confused that segment 0 is the 0 outside the sliding window. No, Please, in this context, segment 0 is something else. Segment 0 is the start of the sliding window. Up to segment N are retransmitted. And in the selective request, only the lost packets are selectively retransmitted. We will cover both one by one. First, let us go back N because it is slightly easier to understand. In the go back N ARQ, suppose this is the situation. So suppose say the window size is capital N. The base of the window is this currently. The ones shown in dark blue color, already those has been acknowledged. So they have gone out of the window. The ones shown in light blue color, they have been sent, but they have not yet been acknowledged. The ones shown in gray color is not yet been sent. Okay, so they are of little concern right now. The question is, what happens if timeout occurs for any of these light blue colored frames? That is the question. Okay, what will happen? Let us see. Consider a situation where the sender is allowed to send maximum 3 frames at a time. This is a situation of sending 3 frames at a time. So the window size is 3. Okay. Fine. Let's see what happens. First, it sends frame 0 and starts the timer immediately. Then it sends frame 1, starts the timer. Then it sends frame 2 and starts the timer. Okay. Now, it wouldn't have sent frame 3 immediately. Okay. But what happened was that it received the acknowledgement for the frame 0. So when it received the acknowledgement for frame 0, it said that, well, fine. So my business for frame 0 is over for now. Again, later on frame 0 will come, but that will be a new frame 0. The sequence number here is not clear from this diagram. We don't need to bother about it. After how many frame numbers would frame 0 come back? We don't need to bother about it right now. But it receives the acknowledgement 0, it closes the timer from send 0, it moves the sending window 1 position to the right and it sends frame 3. After sending frame 3, it receives the acknowledgement for frame 1. It says my business with frame 1 is over. It closes the timer for frame 1 and it sends frame number 4. Now, this was okay. Only problem was that it is not receiving the acknowledgement for frame 2 because the acknowledgement for frame 2 got lost somewhere. When it got lost, frame 2 timed out because every sent out frame sent out as an independent timer associated with it. So when frame 2 timer timed out, okay, it is go back in. Okay. Go back in says that it becomes very nervous. It says something that I had sent out earlier. Okay. For that, a timeout has happened. So I have to resend that frame, no doubt. But in the meantime, I have also sent out some other frames. Maybe those have also not received the sender. I don't know what is happening inside. What is happening, I don't know. So it gets extremely nervous and it sends out all the frames that it had sent out till now in its current window. Remember, now its current window is from frame number 2 up to something that is again not clear. If we assume that this window size is 3, then it is frame number 2, 3 and 4. Say length 3 window. So it says I have sent out 2 that has timed out, but I have also sent out 3 and 4. So I don't know what is happening. Okay, I mean, it gets very nervous. And it other than 2 and 3, it also sends out 3 and 4. Okay. Now the question is, was it necessary to send out 3 and 4? That is questionable. Because maybe something bad happened with 3 and 4 is fine. But maybe 3 and 4 that was sent out earlier properly reached the receiver. Okay. Maybe their acknowledgements are taking some time to reach the sender, but they will come back eventually. Okay. But main thing is receiver might have reached it. But unfortunately, the sender has no way of knowing what happened with 3 and 4 also. It only knows something bad happened with 2. But it also does not know what happened with 3 and 4. So it sends out 2, 3, 4 again. This time, luckily, 2 reaches the receiver, 3 reaches the receiver, and 4 reaches the receiver. Of this, it accepts 2. In the receiver, when 3 and 4 reached, okay, it will accept 3 and 4 this time here at the big when the first attempt it reached, and probably it will also send out the acknowledgement. Those have not been shown. But what is important to understand is that the next time 3 and 4 also successfully reaches it, it again acknowledges 3 and 4. It need not again store frame 3 and 4 because it has already received them. But even if it had acknowledged 3 and 4 earlier, it will again acknowledge 3 and 4. This is important for sliding window protocols for the sender side window to move to the right. Otherwise, the sender side window gets into big problem. It does not know what is happening to 3 and 4. Okay. Because these acknowledgements that the receiver for 3 and 4 will send, they will not be accepted by the sender. Okay. This will not, because it works in strict order. This particular protocol. These, even if this 3 and 4 comes, they won't be, the sender won't bother about them. So it is important that you again, if you receive a repeated frame, you understand that okay, this is a repeated frame being sent back by the sender, but you acknowledge them. Similar thing also happens, I think, for this thing, the stop and wait protocol. If a repeated frame is sent, the duplicate frame is discarded. It is not accepted, but it is acknowledged. Otherwise, again, the stop and wait basically window cannot move to the right. Stop and wait is a very simple length 1 sliding window protocol, basically. Okay, where the center length is 1, window length is 1. So that there also this similar thing exists. So do you think this is very efficient, students? What is your comment about the efficiency of this scheme? Anybody, any comment about the efficiency of this scheme?
We need to keep the previous packets in store also in memory.
Previous packets in store means
I
which
mean,
side, sender or
after
receiver?
sender side, if we want to say go back n packets before, then we also need to store them, keep them intact, right? Because
Yes.
once it is sent,
Good. Very good. Yes. Yes. Yeah. So his point is something like this. What he is saying is, suppose you get nervous because this packet numbered base has timed out. So the sender gets very nervous and sender has decided that I will now resend the packet numbered base, which is okay. But the problem is that it will now need to store, need to send out everything which is up to this light blue color. All these 8 segments it will send out.
Sir,
But
but the
your answer is not that well, it might not be a problem because anyway it would have needed to store this for some time until it receives the acknowledgement for this. Right? Any sliding window protocol, until it reaches an acknowledgement, it doesn't move the window beyond it. So these other guys probably acknowledgement also hasn't yet been received. It will not receive acknowledgement out of order. Okay. So that probably is not a problem, and the most chances of a timeout happening is for the left hand side of the sending window. Otherwise, can timeout occur for anything in between this window if there is no out of order kind of thing?
No.
Because if it receives successfully an acknowledgement for what is shown as base, it will move the window one position to the right, and it will now become from base plus one up to whatever is this first white, and the first white will now become gray, and this something shown base will now become dark blue.
Sir,
Yes.
sir, in the go back in process, if suppose the acknowledgement of 2 is timed out, means it, but it could be possible that the acknowledgement of 3 and 4 would come in time. Then also it is sending again the packet of
Yeah, but
3 and 4.
the problem is, see, the problem is even if 3 and 4 comes in, acknowledgement for 3 and 4 comes in, it will not notice. Now let us have a look at the timing diagram. Notice the self loop label on the top and the self loop label on the bottom. Okay. The receiver,
Sir, could you please repeat?
the sender side, when it gets acknowledgements, it only receives the packet and moves the timer one position, moves the window one position to the right, which is the same as changing the base. Okay. It stops the timer, which means it's business for that is over if it is the next sequence number expected. Next sequence number expected from the top position, you will understand it just keeps on increasing sequentially by 1. So what happens is that if 3 and 4 acknowledgements suddenly come back, okay, even before the acknowledgement of 2 has got lost, okay, even if 3 and 4 comes back, they would be ignored on the sender side. It does not have the ability to receive acknowledgements out of order. It does not have the ability to send frames out of order. It does not have the ability to receive acknowledgements out of order. Okay, everything is strictly in order, which keeps life simple to implement because it is simpler to implement, but it can be inefficient. Okay. So as you said correctly, that it is highly possible that acknowledgement for 3 and 4 will come back, but they would not be received by the sender side, saying no, I have not heard anything about 2 right now. How can I receive the acknowledgement for 3 and 4? Okay, so it resends on the receiver side if 3 and 4 had earlier been received and acknowledged. The 3 and 4 data will be rejected, but they will again be acknowledged. And this time the sender probably will receive all pending acknowledgements. So when it receives all pending acknowledgements 2, 3, 4, it makes a large jump. Okay. So what I mean by a large jump is that suppose in a particular very severe case, because this base timed out, it sent out all these frames again. And this time it received the acknowledgement of all the frames together, one after the other. Okay, in sequence. In that case, it makes a quantum jump over this entire light blue space, and the window goes to the directly to the first the first position that is shown gray here. So in this case, in this diagram that was shown, when 2, 3, 4 are received, it is over. Its business with frame number 2, 3, 4 is over. If frame number 5 is allowed, then it goes. Now the window moves to frame number 5, 5, 6, 7, and whatever is the length of the. If the length of the window is 3, then 5, 6, 7 is the new window. Okay, so it has the ability to make quantum jumps if it receives the acknowledgement of several outstanding packets and one go. But out of order acknowledgements, it does not have the ability to receive. Okay, it receives the acknowledgements in order. If there are multiple acknowledgements in order, its window kind of shoots forward, moves very fast forward. That is okay. But it has to be in order.
Sir.
Yes.
Sir, can there be any chance of implementation that suppose the base is now at for the frame number 2 and the acknowledgement is not received in time, so we can shift the frame 2 packet, means the to the at the next sequence number position or something else, and the base will be at for the 3.
Yeah, that is what we are going to study next. It is called selective request. That I for a moment forget that I have not received something. I mean, not forget, I remember that I have not received something, but I allow the next ones to kind of deal with them. Okay. Something like this. This is called selective request or SR. In this, the state diagrams will be more complicated. You can draw your own state diagram if you want. But the sender window and the receiver window now looks like this. Now there is some peculiarity. Earlier in this, when this range of light blue colored segments, there was no dark blue colored segment. There was nothing received and acknowledged out of order. This time now we give the freedom that you can now receive stuff out of order. Okay. So look at this. Some are already acknowledged, which means that they were sent and I have received acknowledgement, so I can forget about them. This dark blue colored segments on the extreme left. So forget. Then there are 2 segments for which acknowledgement I have sent but not received any acknowledgement. Now in between there are 2 segments for which I have sent and I have received the acknowledgement, because now I have the ability and the freedom to receive acknowledgements out of order. So if these are packet numbers, say 0, 1, 2, 3, okay, let's see what is the window size. Well, window size and sequence number is difficult to say. So this window size is n. So okay, fine. No, just forget about. So this is send base. This is send base plus 1. This is send base plus 2 and plus 3. Send base plus 2 and send base plus 3 I have received. send base plus 4 I have not yet received, but then send base plus 5 and 6 I have received. Send base plus 6 I have not yet received in this way, and the remaining are in gray, which is means I have not yet sent them. I could have sent, I mean, when I receive them, I will send them. Look at the receiving window now. Receiving window also is peculiar. In receiving window now, the receiver window says, oh, I have sent out the acknowledgements of the others, so I don't bother about them. Okay, somewhere the acknowledgements are there. My receiving base is I will receive this when it comes, but I have received 3 of them afterwards. Why is this the third one in deep blue on the receiver side and light blue on the sender side? Can anybody explain?
Sender has not received the acknowledgement.
Yes, sender has not yet received the acknowledgement, but the receiver has received the packet. Then it has sent the acknowledgement. It is still to say reach the sender, or maybe it has got lost on the way. Don't know. Okay. So this now gives the freedom. Now, if the receiver finds these gaps in its receiver window, saying, look, well, I have received many packets, but one I have not suddenly, there is a gap. I have not received the packet also. It requests, please send this packet. Okay. Or it selectively acknowledges something. By the way, the receiver side acknowledgement for go back NARQ is a cumulative acknowledgement. What is meant by cumulative acknowledgement is that if I send the acknowledgement number, say 2, that is in a way it tells the sender that receiver had received everything between 0 and 2, 0, 1 and 2. So if the receiver sends acknowledgement 3, it means it has received everything perfectly between 0 and 3. So it is a cumulative acknowledgement of everything received perfectly from the beginning of the sequence number till the one that has been acknowledged. In selective request, that might not be the case. Okay, so let's see an example. So here the sequence numbers are 2 bits. So the sequence number space is between 0 and 2 power 2 minus 1, which is 3. So the sequence number is between 0 and 3. The window size is 2. Okay. Now the sender window first is between on 0 and 1. When it receives the frame number 0 from the application, it sends it. The receiver and also 0 and 1, it successively sends. Now, when the receiver sends an acknowledgement, this diagram, okay, for the first time shows a convention where the acknowledgement number is for the next expected segment. Okay, please remember this. This is slide number 54. This is a diagram which shows the convention of that is actually used in TCP. This is also kind of a cumulative acknowledgement. Right, because this is saying that, well, I have received 0 and 1 and my next expected number is 2, means I have received everything perfectly as 0 and 1. The problem with not acknowledging individual frames is that now if you do not receive a frame, you have to send a special package called negative acknowledgement to the sender, NAC. saying I have not received something. Please send it to me. Now, suppose it sends frame 2 and it is lost on the way. Then frame 3 is sent. After receiving frame 0 and frame 1, receiver window is also of size 2. It had moved on positions 2 and 3. Now, when 2 was lost anyways, nothing was received. Then 3 was sent because it was in the allowed sender window. When 3 came to the receiver, it received it. Earlier in the go back end, receiver wouldn't have received 3 because it had not received 2. It wouldn't even have acknowledged 3. It wouldn't have done anything about 2 and 3 because 2 got lost. But this time it says, well, I am allowed to receive frames out of order also. So, okay, I will receive 3. But I will put 3 in my in its proper place in my window because it is my allowed receiving window. But you know, I cannot slide my window to the right immediately. Why? Because there is a gap in my receiving window. 2 has not yet arrived. So it sends back a special negative acknowledgement 2 packet to the sender. Negative acknowledgement 2 sends that I have not received 2. Please send it. And when sender receives this, it resends 2. It could also have resent 2 if there would have been a timeout interval. Then receiver would have received 2. And if that happened before frame 3 was received and then frame 3 was perfectly received, it would have cumulatively acknowledged up to frame 3 by sending SEK4 packet. Oh, SEK4 is not there. It would have said SEK0 basically, which means that, okay, I've now my expected frame number next is 0 because its sequence number space is over. This is a toy sequence number space which only allows 4 sequence numbers. Okay, again, why did we keep ourselves confined to only 2 window size? There is a reason. Those we will study in the next class, where we will discuss why in selective request ARQ there is a limit on the window maximum allowable window size, and in go back end there is another different limit. Okay, and we will see with examples what is those limits, what are those limits, and if you do not respect those limits, how you can get into trouble. Okay. Any question about this, students?
Sir, sir, what about the case when sender doesn't get the acknowledgement?
Then sender will time out and resend. And if the receiver has received that packet earlier, okay, it will ignore the content of the packet, but it will resend an acknowledgement to the packet. An acknowledgement to that packet by sending probably a cumulative acknowledgement telling the sender that I have received this till this. There are 2 mechanisms by which the sender can resend a packet. Those can happen very frequently for different packets. One example is where an explicit negative acknowledgement was received from the receiver, telling the sender, please send. I did not receive this, please send it to me. This negative acknowledgement type of thing can only happen in selective request ARQ. It does not happen in go back N ARQ because go back N ARQ is perfectly in order. There is no question of receiving packet frame 3 like it happened here before receiving frame 2. Receiver will not receive frame 3 in go back N. In this case, it will receive. And then it will send back that there is a gap in my window. Please send it to me. It could have been that say if this window spanned over 2, 3 and 4 and receives 4, then it would have sent back 2 negative acknowledgements that I did not receive 2 and 3. Please send them both to me. And then the sender resends them. This is the first case. Second case is the timeout mechanism still exists. That is fundamental. These are all automatic. Fundamentally, these are automatic repeat request protocols. Okay, automatic repeat request means there is an inherent timeout mechanism for every segment. That is a basic property of any ARQ scheme. That has not been shown here because the diagram would become too clumsy. So many concepts would be combined, but that can also happen, that the sender times out. It has not received any acknowledgement from the receiver, then it resends, and accordingly the receiver will, if it has received, it will receive. Okay, if it has not received, it will receive for a selective request out of order. If it has not received but it is out of order, it will reject and not acknowledge in go back in. And if in both the cases, go back in and selective request, it has received earlier, still a duplicate packet is coming, it will not receive the data content of the packet, but it will acknowledge the packet. Okay. So read the book. This topic is very, very nicely mentioned in Kuros and Ross. Okay, for this topic, I would suggest this topic and TCP, several aspects later on which we study. I would suggest please study Kuros and Ross. Okay, it is a better book. All these many different situations are given of all the different things that you are mentioning. What will happen if timeout happens? What will happen if acknowledgement is lost? What will happen if packet is lost but it has been received earlier at the receiver? What will happen if packet is lost but it has not been received earlier at the receiver? All these cases are different cases are covered with nice diagrams. Please have a look. Okay, and we will continue this discussion tomorrow. Thank you. I'm now stopping the recording.